You will see that performing a t-test in Excel is simple, provided you have the analysis tool pack. So first, load your data into Excel using the familiar procedure in the Data ribbon. Now you will see that in Excel, it is only possible to read data into the t-test if they are stored in two clearly identifiable arrays. As far as I know, there is no simple way to tell Excel to create the two groups automatically, as in R, on the basis of values of some variable. In our case, we want Excel to compare the Human Development Index of EU members and EU non-members. There is no simple way to tell Excel that EU, or EU member here, is the binary variable that defines the categories, or the two categories. What we can do, however, is to simply sort the data according to this variable, and this way we will get two clear groups of data we will then be able to use. To perform an unequal variance independent samples t-test, go to the Analysis toolpack under the Data Analysis, under the Data ribbon, and select t-test to sample assuming unequal variances. For variable range 1 or variable 1 range, select the values of Human Development Index for all those cases for which EU member is equal to 0, so EU non-members. For range 2, we insert the Human Development Index values for everyone else. So for those countries with value of EU membership equal to 1. We can leave all the other options as they are. Performing the t-test will create a new sheet with the reported results of the test. Now in the output, we can see the basic statistics about the two groups of EU non-members and EU members, their mean, the variance of the data, and the number of observations. You may remember that indeed there are 28 EU non-members in our data and 18 members. Line 9 gives us the t-statistic, minus 4.131236, and note that this is exactly the same value as R gave us earlier today. Now lines 10 to 13 give us the results for two possible options of the test, one-tailed test and two-tailed test. Remember that one-tailed tests are used when we have a clear expectation of the direction of the relationship. Two-tailed tests are used when no such clear expectations exist. One-tailed tests are more likely to give us our positive results, so the results we would like to see, that there is a difference between the groups. Normally, we report two-tailed tests, however, as the default, because this test is more conservative. It is automatically less likely to give us the expected results. So if we still get a positive result, even though we used a two-tailed test, we can have more confidence in it. This way we are trying to protect ourselves from type 1 error, even though we are running a bit the risk of running into a type 2 error, as we have also learned. Now, lines 10 and 12 are the important ones here, giving the probability, or the probabilities, that the null hypothesis of no difference between the groups is correct. If you look at line 12, it will give you this probability for a two-tailed test. And you will find exactly the same result we got from R, that is 0.00027. The one-tailed test result on line 10 gives a number that is exactly half of this one, which corresponds to the fact that the two-tailed test needs to distribute all the 5% of uncertainty available on both sides of the probability distribution, as you may remember from the class. So anyway, line 12 is what matters most here. We see that the value reported is much lower than 0.05 or 5%, our alpha level criterion. Hence, we can conclude, as we did in R, that the two groups differ in a statistically significant way from each other. Now, if we go back to the data analysis menu, we will see that we also have available a two-sample t-test assuming equal variance and a paired sample t-test. Their options are exactly the same as in the two-sample t-test assuming unequal variance, and the procedures to get the results from Excel are also the same. So this is it for today, and for the t-test you can see that it really is not difficult at all. A single line of code in R is sufficient for you to perform the basic t-test. In Excel the procedure is almost equally simple. So good, bye bye.